Last week I did a video repairing this fireplace grate. What happens is over time, these have a tendency to burn out. They're made out of cast iron. Then they fail. We get about a year out of one of them. Well, I ended up making a bottom for one of these out of some 3/8 plate steel. If you want to check out that video, go ahead and take a look. But I decided this week I'm actually going to make one from scratch. And then when I'm done, I'm going to upload the plans to our Facebook welding community page. And I'm going to share it with you guys so that if you want to build one for yourself, you'll have the plans. Or maybe you might want to build a few for yourself, sell them locally or online to make a little bit of side cash. Let's get going. I'm going to try to keep this build really user-friendly, using the minimum amount of tools so that you can get the most amount for your investment. So pretty much for the tools we're going to be using for this is a welder and a plasma cutter. I'm going to have a set of plans and I'm going to upload those onto Facebook. These aren't them, but I'm just kind of showing you a sketch of what I've got. Roughly how big it is, 20 inches across the back, 23 across the front. We're going to have some slices in it to let airflow come up through. It's going to have 3-inch sides, probably at about a 15-degree angle, but I'll have to verify that. And it is deep-wise 12 inches. You guys can make some pretty good money. Go online and Google Fireplace Grate. They range anywhere from like $30 for something cheap up to $750. So there's money to be made in these, especially if you can pick up some plate that is otherwise useless for something else. As you can see, this plate is all warped up. You can see how it's got a lot of bends in it, but that's going to be perfect for doing a fireplace grate like this because all it's got to do is hold fire. I'm always looking for ways to show you guys different ways of doing something, things to think about, and maybe even some ways to make a little bit of extra money to better your circumstances. This could easily be made and sold online. Like I said, some of these go for $750. And there are people out there that are willing to pay for quality that don't want to have to deal with replacing their fireplace grate every year like I have to do. Let's get going. As we do this project, I'm going to show you the tools that I would use to get the most amount of money out of these if you're going to build them, or the way to do it that will cost you the cheapest. Basically, you're going to want a plasma cutter and a stick welder. That's going to be the best way to do it. The consumables for a stick welder are the cheapest, and it's going to work great for this because it's 3/8. If you decide to use a MIG welder, you're going to have to do this with a 220 volt machine because this plate is 3/8 thick. A 120 volt machine just really is not cut out to go past 1/4 inch, and that might even be pushing it with flux core. So that's why I say a stick welder is the best way to do it. You could do this with a DC buzz box, or you could do this with an inverter stick welder, using 6010 or 6011 rods depending on which welder you're using. So for visuals, we'll get this thing laid out 23 inches. We'll make a mark there, and we'll make a mark on this side. Now I'll just use a straight edge and connect the two. And then it's going to be 12 inches deep, so we'll put a line across that way. 12. We'll get all our pieces cut, then we'll do all our welding. These are also great projects, guys, if you're starting out welding with like very little liability. There's not a whole lot of liability in building something like this. If your weld cracks or if it fails, nobody's going to get hurt. So this will be the bottom of our fire grate. These will make up the sides because these little lips right here, those need to be 3 inches tall. So that'll be 2 3-inch strips out of this. That'll go at probably a 15-degree angle, but we'll have to figure that out. And when I upload these plans, I'm going to make it so that you really don't have any waste. So if you have to either buy the plate or you look for it, you'll know the minimum size that you need. And we're going to try to maximize how many cuts we need to make, because obviously the less amount of cuts that we make, the longer our consumables will last, which means that we're going to get more of our consumables and make more money. First thing we're going to do is I've marked out how big this plate is. So it's 23 by 12. That's our first piece that we're going to cut. And that's what it converts out into for metric. And then that leaves us about 6.5 inches left over approximately. And we said we wanted each of these like 3 and 3. What we're going to do is we'll make this cut first, and then whatever this is, we'll just divide it right down the center, make one cut, which will give us 2 pieces, and then that'll be you know, the angled side, one for here, one for here. I'm using the Cut 55 DS for this, but next week I'm going to be using the Cut 55 DS Pro, and I'm going to be going through all the features. But you can pick that up for like $265, and I've got promo codes and links down below that you can buy through to save you even more money. Now we need to set this machine up for the correct air pressure and for the correct amperage setting. Just like you wouldn't take a cutting torch and max it out fully for sheet metal, you want to do the same thing for this because it maximizes your consumables. What I want you to do is head over to our Facebook community page, and at the very top of the page you can see we've got buy and sell, we got featured, photos. Viewers can share and upload and interact and comment and ask questions. It's just an awesome place to be. It's one of the best welding communities on the internet. Click on files and you can go in there. You can see all kinds of things. Here's one right here, target stands. You can make a little bit of side money. It's got the prints and how to make those right in there. We're going to be adding this fireplace grate to make you a little bit extra money, but what you're looking for is the plasma cutter chart. You're going to go in there, click on it, you're going to download it. Then you're going to go into the folder wherever you keep your downloads and find the material thickness that you're working with. For us, we're working with 3/8, so you can see we need to set it for 40 and 40, so 40 amps, 40 psi for 3/8 metal. And you come over here and you can see we're already set for 40 and 40. That'll just help preserve your consumables. I would love for you guys to come over to our Facebook page and join us over there. It's just a super awesome group of people who like to share stuff, ask questions, and there's just all kinds of talent over there. You guys will get all kinds of ideas if you head over there and join up. In last week's episode, I showed you that I used a 7 1/4 inch circular saw with a metal cutting blade to cut this plate steel, and it cut just awesome. And that's good if you're going to do just a few frequent cuts. If you're going to make a lot of these, I'd recommend a plasma cutter because, in my opinion, a plasma cutter is pretty much the ideal tool for cutting plate. And it's probably one of the cheapest ways of doing it because the only thing you're buying is consumables after a while. So you've got, you know, $265 invested in this machine. You're going to need a few consumables. It helps to have really dry air with a plasma cutter. And if you want to know all about plasma cutting, I have a video called Plasma Cutting 101, and it explains everything in great detail. It's a really popular video. Although this has what's called a drag tip on it, you see how it has like a cross? That drag tip is made that it can go directly on top of the plate and touch it, and the metal squirts out from the sides. But if you can hold it off the metal just a little bit, you'll actually get a little more life out of your consumables. And you can see by using this 3/8 plate and just dragging it down this piece of ceramic right here, it actually holds it off the metal just a little bit, and it'll give you a nice straight edge to go by. And that's what we're going to do because it'll extend the length of our consumables. I'm going to put on some cutting goggles, and I also like to use a shield just because sparks fly, and you're going to want welding gloves. And you're also going to want a respirator because it's not good to breathe in these fumes. I wanted to stop this cut real quick and show you why I took that spacer off. For one, this plate is super bowed like I told you, and it was making the gap higher and higher as I started sliding it down it. But look at the kerf. So the kerf is real wide right here as I slide it along, and then look how thin the kerf gets right there. And the reason for that is that's where I was dragging it. By using that spacer and having it off the metal a little bit, it's acting like the metal's actually thicker. So the machine is not piercing it as cleanly through it. So I'm going to drag it because I'm getting a faster, cleaner cut. If this plate was a lot flatter and it didn't have all kinds of bows and waves, this would be a good way of doing it using the straight edge, but this plate is just too jacked up to do that. So here's our bottom right here of the fire grate. Then it's going to have the squares cut out, and we'll do that eventually. And then here's the scrap. Now we're going to take this scrap, whatever this is, and just cut it right down the middle, just to make things nice and simple. It reduces the cuts that we got to make. The scrap that we have left over is 6 5/8 wide. Divide that by 2 and that gives us 3 5/16 or 84 millimeters. So we're going to put a line at 3 5/16 or 84 millimeters, draw it right down the full length of it, make one cut with the plasma cutter, and that'll be both sides. So now we've got our 2 strips cut that are both 23 inches long or 584 millimeters. Now we're going to go back to the bottom of our plate for our fire grate. So this is how we're looking at it right now. We got 23 inches along the back right there, and we need it to be 20 inches along the front. So to get that measurement, we're going to come in 1.5 inches and make a mark, which is also 38 millimeters. Do the same thing on this side. Come in 1.5 inches, 38 millimeters. Then we're going to draw a line from here up to that edge. That'll give us that taper that we're looking for right here and right here. And then we'll have to make one of these plates right here 20 inches long to match what this will now be. This will now be 20 inches inside to inside, or 304 millimeters. And while we're doing this cut and this cut, let's cut that to length as well. So we know that it's going to stop there, it's going to stop here. So let's just hold it up, put a mark right in line with this mark here on the plate, and we'll cut this off straight across right there. Now we need to put in the slots onto this plate. So we need to know, where do they begin and where do they end? Because obviously you can't go all the way to the end, because it's gonna it would cut it in half. So I'm going to use 2¼ inches or 57 millimeters. How'd I come up with 2¼ of an inch? That's the width of this. This line that we just drew with that level from that edge, going to come in 2 inches. I'm going to use a piece of 1.5 inch wide square tube as a template. Okay, and that's what I'm going to trace out. Those are going to be my slots. Okay, so from the center of this tube, we're going to make a mark every 5 inches. So it would be 5 inches, which is also 127 millimeters. Another 5 inches will be the tube, then another 5 inches. So that'll give us equidistant slots all the way down through this. And to keep my line somewhat straight, we'll use a straight edge. I'll bump it up against this plate right here. I mean, they don't have to be perfect. Like I said, this just got to hold fire, right? Check it for 2 inch, that looks great. We'll move this over, line it up here to my center mark, which is 5 inches away from that. Put my framing square on it. You can see I gotta come over a little bit, and there we go. And now, just like all the others, we're just gonna cut out these slots. Cut out that, that, and that. These could actually be cut up and made into legs if you wanted to, and maybe we'll do that. I haven't decided. I kind of was just going to go for some square tube just for the looks, but I don't know. Maybe we'll just keep it really inexpensive and use these cutouts for the legs of this. So we're ready to start welding. We still have to figure out if we're going to use these pieces that we cut out and use them for legs. I'm leaning towards that. I actually think it would look pretty good if we did, and it would be cost effective if you guys are building them. You see this on here, this little ridge that's all around? What that's called is called dross or slag, and what we got to do is knock that off, and that comes off really easy with a chipping hammer. And that's all we got to do to get ready to weld is knock off this dross. And you can see, watch how easy this is. Hopefully you guys can hear me okay because I'm wearing a respirator right now. About what I'm going to do is go around and prep this edge so we can get it down to bright shiny metal so we can make our welds. I think you guys are going to like how we're going to do this next part. It's going to be pretty slick and it's going to save a lot of time. So these I am going to make into legs, but not for everywhere. So what I'm going to do is I've got some 1-inch square tube laying around. So I'm going to do square tube legs on the front like this, just so it looks a little bit fancier. It's going to be short, so you won't really see them all that well anyways. And then where you don't see these, I'm going to put legs here, 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 and then in the center of these ribs so they can't bow. Then once we get the legs welded on, we'll get them all cut to length. That's where it's going to save some time. So I'm going to make a jig and it'll mark them all, because you can see, look how warped up this is. You can see this isn't even off the ground. It's like this is like the thickness of my finger. It's not even flat. Then over here, it's touching right on that very edge. And then over here, it's even thicker. So what we're going to do is we're going to measure off our table and then just make a line and make it even all the way around. I'll show you. It'd be pretty slick. As I said earlier, the most cost-effective way to weld this up would be to use like some 6011 or 6010 rods with a stick welder. That definitely is the cheapest way to go. It's the cheapest way to purchase the welder, for one, and it's the cheapest consumable that you can get. The next, probably cheaper, would be to use like a flux core welder. But I'm not going to use a stick welding process simply because it's cold outside right now and I'm working inside. And as you guys know, stick welding makes a lot of smoke. If it was summer where I could open up the door and get more ventilation, I would definitely stick weld this. But it's winter time, so I'm actually going to MIG weld it. For CFH, I'm running right about 15. We're running at 194 amps or 555 inches per minute, 27.6 volts. Now these ones, guys, you're not going to really see. So, I mean, you can try to get them pretty good or as perfect as you want, but you're really not going to see any of them. Alright guys, these are the ones I measured. Look down them. Those are pretty darn straight for what it is. These are the ones I just eyeballed and guessed. Those are pretty straight too. So sometimes it really doesn't much matter, guys, as long as you get it fairly close. And the more you do this stuff, the better your eye gets anyways when you start doing stuff. So now let's put a tack here, here, and here, and then kind of just a couple more tacks on those over there. Then I'll get these all welded out. Then we'll cut off so they're all even. Now we're going to flip this over and we're going to weld on our ribs on the front and back. Then we'll cut our feet. That way if there's any warping or anything, it'll all be done. It'll all have been welded. So it'll be warped to where it's going to warp. Get yourself a magnet and then you can do it this way. Just like that.
Alright, all we got to do is weld the back side and then cut the legs, and we are just about done.
When we're all done with this, guys, and we get this all cut, I'll throw this on a scale. This is really, really heavy duty. We're all welded out, guys. Not the prettiest in the world, but you know what? It'll do. It'll work. And that's really all that matters. This side came out good. I got all kinds of wormholes and porosity over here. And you could actually hear it when I was running it. And that's just basically just trash that's inside there because I didn't clean it enough. But like I said, it doesn't really matter, guys. It's not the end of the world. This was a pretty rough plate. If this was actually a nice flat plate and I had some good material to work with, I probably would have taken my time a little bit more. But I'm basically just doing this so I can have something for myself, and then I can make some plans for you guys and show you how to build one of these and do it cost effectively and be able to make a little bit of money while you're doing it. Kind of looks like Stonehenge over here with all the different height legs and everything else. Now we're going to make them all the same, and I'll show you how we're going to do that. Now I've got a couple scrap piece of metal that I'm going to set on either side of this, okay, just like that. Then I'm going to set my straight edge right on top of that, and that's going to give me a nice straight line that I can trace down to make all my legs perfectly the same height. There's the line we got to cut them off at. Do the same thing for the middle row. And by doing it this way, guys, doesn't matter if one of these is like leaning this way a little bit, it's going to be flat all the way through the way it should be. Now we could easily take the plasma cutter and cut all the way through this. But as you can see, I've made a nice crisp line because I want to get it fairly straight so that it doesn't rock. And that's kind of hard to do when you're doing it on tubing. So what I'm going to do is I'm going to use my portable bandsaw. So this is my portable bandsaw, but I have it set up as a bandsaw table. And I'm going to show you now how easy this is to take off. I don't take it off very often. So this loosens up. This clamp stays on here all the time. Then back here, here's the plug-in. That unplugs the saw. When you turn on this switch, it powers up this outlet. When you turn off the switch, it turns off the outlet. Now the saw will come right out and just pulls out like that. Now I've got it turned up on end so I can let momentum do its work, and now we're just going to chop it off. Look at that, no wobble, guys. So when you open up the fireplace, this is pretty much kind of what you would see. You wouldn't see it very well though, just because it's kind of dark in there. But you can see how now these feet are all touching, and when this gets glowing cherry red, because it'll have coals down under it that are heating upwards, what's going to happen is that these legs that are down here, these legs are going to keep this from bowing down in the middle and sagging. Same thing from the middle. This little strong back is going to help do that, help it from bowing. So this should last a really, really long time, guys. And these are all the little pieces that we cut off at all the oddball lengths. And this is how you polish up a turd. I shouldn't say that. That's just a figure of speech. In all seriousness, no, it's a good idea to always, you know, finish everything. Paint it, looks good. It's going to burn off anyways, but it just kind of shows that you took a little bit of extra time. And I rounded off the edges. I made sure that it doesn't have any sharp edges anywhere and that everything feels good. Came out pretty well. I'm happy with it. You can see some porosity over here. That's got some trash in it. It's got some undercut here and there. That's pretty decent there. It's got some undercut here where there's some gaps, but you know, not a big deal. It's going to serve the purpose that it needs to serve. Just like that, I doubt you'd ever see that that's like thick tube, but I just like the idea of having the tube on the front. And then, like I said, these flat plates back there, when this is glowing cherry red, that's just going to kind of keep that from bowing down. So this should last a lot of years. And there's also some other things that you could do, like on the front of this, which you may not see it that well. If you wanted to put like your name in this, or you know, you could write like stencil out like family and then cut it out with a plasma cutter. There's all kinds of cool things you could do. Put your last name in there just to kind of make it custom. This is just to give you guys some ideas, and maybe you guys can make a little bit of money making these and selling them online or selling them locally on Facebook Marketplace. That is heavy, guys. Check that out, guys. 46 pounds. And that's all there is to it, guys. I want to thank you guys for watching. Thank you guys for tuning in. If this is something that you like, please don't forget to rate, comment, subscribe, and share. And if you're wondering about any of the tools that you see me using, I'll have links down below. You guys can get a discount on a lot of those tools that I have listed. New videos every Friday. So until next week, guys, I will see you then. Take care, stay safe, and God bless.